Welcome for today's online academy. Today's topic is descriptors more than just a hashtag. I guess that everybody knows that descriptors in IMOS are indicated with a hashtag in front of it. This is why we made this little pun for the title of the online academy. For today's example, I prepared a small cabinet here that just looks like this. And with this cabinet, I would like to show you a few options that you can do with descriptors. First of all, I think everybody knows already, we use descriptors for linear divisions, which I will, for example, use here for my dowels. In this case, I'm not using a descriptor so far, or actually I'm using one, but I didn't set them up properly. So if I check my connection situation that I'm using for the dowels, I can see that inside of this connection situation, I have a first linear division, and there we see it's written hashtag training dowels. The hashtag tells us that I'm using a descriptor in this place, and if I click on the 3-point button here, I will be able to set this descriptor up. As you can see, in the descriptor that I'm using, I don't have any conditions so far. And first of all, I can add a note to my descriptor, which is quite useful in case you would like to combine it. For example, if you're using dowels and cams, you could create a descriptor that is actually suitable to work together with a descriptor for cams. And then you could just type in a note, this descriptor is actually going together with my descriptor for screws or for cams, for example. That can help from time to time to keep the overview of what you actually created the descriptor for. I will just type in descriptor, or maybe standard descriptor for dowels. And next up, I can change the type of descriptor. So since the version IX 2017, we have the possibility to change the type of a descriptor. So from now, we can not only use them for linear divisions, but also for construction principles. And I will show you later what we can do with the descriptors for construction principles. But for now, I will just set up my descriptor for the linear divisions. I have a sample dimension, which is only for the preview here to test my actual linear division. And it doesn't really matter what sample dimension you type in here. And then, of course, every descriptor needs a default value, or every descriptor should have a default value. In this case, I will have a linear division of 21 millimeters to 1 to 64 millimeters to 1, and then again to 64 millimeters to 1 to 64 millimeters to 1 to 41 millimeters. Of course, for the descriptors, you can always use a formula as well. So you could use a formula which makes the linear division only work in a certain grid. Like for example, if you have the division 1 to 1, you could say the second relative value is in these brackets by 32 millimeters. That means that the second part of my linear division is only able to move between these patterns of 32 millimeters. And as you can see it here, it only jumps every 32 millimeters, and the first part is just relative. It can grow and shrink without any difference of the pattern. Of course, you could also use a formula for a repetition. For example, if you say I want to have a division of 1 3 times, you could just type in 3, and in these width brackets I just type in 1, and that actually means that this division of 1 is created 3 times. So in this case I have 1 to 1 to 1, and which is an easy way to just insert multiple adjustable shelves. For example, if you need 8 adjustable shelves with an equal division, you could just type in 9 to 1 in these brackets, and then you would have your 8 shelves in this case. But as I'm creating a descriptor for dowels, I'm just using my linear divisions. So first of all, I have to set up my conditions. You can add a description for each condition. In this case, I would say the length of my edge is smaller than 100. So actually x, the value x, is smaller or equal to 100 millimeters. And in this case, I want a linear division of 15 millimeters to 1 to 15 millimeters. And I have to translate my description in a certain way so that IMOS understands it. So in this case, I have to add my comparison here. And here I can choose from these different different comparisons that we can use. And here I actually say x is less than or equal to 100. And then I can create the next condition. So I can just duplicate my first one so I don't have to rewrite everything. And my next condition starts at 100 millimeter is greater than x, or x is actually greater than 100 millimeter, and x is smaller or equal to 200 millimeters. In this case, I want a linear division of 21 millimeters to 1 to 41 millimeters. And now I need 2 comparisons. So I create an AND comparison by clicking 2 times on this plus here on the top. And my first comparison is x is greater than 100, and the second one is x is less than or equal to 200 millimeter. And then I will create another condition, which starts at 200, of course, and it ends at 600. In this case, I want 2 more dowels. So I have 21 millimeters to 1, and in the middle I want a distance of 64 millimeters to 1 to 41 millimeters. In linear divisions, you always need to type in the unit if it's not a relative value. So don't forget that. And then I will just create a last condition, which says 600 millimeter is greater, was x is greater than 600 millimeters, and x is smaller or equal to 800 millimeters. And in this case, I will just have a bigger distance in the middle. So in this case, I want to have 128 millimeters between the dowels in the center, and then I just change my condition to greater than 600, and less than or equal to 800. I forgot that here as well. Greater than 200 and less than or equal to 600. So now my conditions are done, and I can actually apply this descriptor to my connection situation, and I apply this for my construction principle. I'm using the same connection situations in the construction principle for my bottom shelf as well as for my top shelf. So now I can try them out. So here you see I'm using the same connection situation for the top shelf as well. And to try out a descriptor, you actually have different possibilities. Whether you just try it directly on the article itself. So now you see my article has a depth of 500 millimeters. So I get my linear division of 21 millimeters to 1 to 64 millimeters to 1 to 41 millimeters. That is actually the second last condition that I created. So if I change the depth to 600, I should get the exact same result, because my condition says if x is smaller than or equal to 600, it takes the same linear division. But as soon as it gets bigger than 600 or deeper than 600, let's say 600.01, I get the distance of 128 millimeters between the dowels. So I see that my descriptor is working. And another good way to just test a descriptor would be, for example, in the article designer, in the dividers, where you can actually add your linear division. Click on the 3-point button, and then you get this small window here. This is actually a window to try out your descriptors. You can choose your descriptor from here, apply it, and then you see how it actually behaves. So you see everything that is bigger than 800, I have no condition for this in my descriptor, because it stops at 800, and everything that is bigger than 800 will actually use my default value here on top. And you can see this, as soon as it jumps over 800, I get additional dowels. Yeah, you can also change the length here. So if you want to try it for a smaller pattern, then you can just type in the total length on the bottom. Okay, so I don't apply this right now. So I guess this is nothing new for most of the people that are watching this online academy. Let's come to descriptors that are from the type construction principle. So I will change back the depth of my cabinet to 500. And the next thing I want to do is I want to set up a descriptor that actually automatically chooses a single door or a double door. In that case, I can modify my article, and you see that I'm using a construction principle for a door here, but actually I would like to use a construction principle descriptor at this position. So the first question is how to choose this construction principle descriptor. Some features that are really good in IMOS are sometimes well hidden. So you have to know that on the 3-point button here to choose the construction principle, you have to make a right click, and then you can choose between construction principles or descriptors. So of course I will choose a descriptor here, and I will set up my descriptor first. So I created something here already, doors, and here I have a descriptor that I called training door wall cabinet, but I didn't set up the descriptor so far. So this time I will choose the type construction principle, and next up I have to choose what type of construction principle I want to use it for. So in this case, I would like to choose a door with this kind of descriptor. And again, I can choose a default value for which door should be taken. My default value will be my single door onset with cup hinges and a pull on the door or a handle. And then I will set up my first condition, where I will choose the same construction principle, and I say that my article width is smaller than or equal to 600. And here you see you can choose a lot of references for construction principle articles. That actually gives you a lot of options, a lot of possibilities how you can actually use a descriptor of the type construction principle. And I will later show you kind of a interesting way how to use it. So, but first of all, I am choosing the article width here. Where is it? Article width is less than or equal to 600. And then I duplicate this condition again. And I say 600 is smaller than the article width. And my article width is smaller than or equal to, let's say, 900. I won't build a wall cabinet that is wider than 900. And in this case, I want to choose my double door construction principle. And I add my condition here. Article width is greater than 600 and less than or equal to 900. So actually my default value doesn't really make sense. If my article is wider than 900, I would get a single door. Actually, I could rather use this blank if I want to avoid having a door that I would not produce, or if I would have the possibility to create a cabinet that I would not produce in that way. Or I just choose a double door in this case as a default, so that I at least have a double door when my article is too wide. Okay, now I apply this descriptor, and then I can already try it out here. So if the width is 600, I still have a single door. If my width is 600.1, you already see a gap here. So my descriptor is working, and it automatically chooses the right door now. But to be really sure, let's try it out in the drawing space. So let's change the width here. Width is 600. Let's make it 800. Okay, so this is working so far. And the next step I would like to use a construction principle descriptor for is the use case that if I change my fronts to glass fronts, Could be an aluminum frame with glass, could be a wooden frame with glass inside. Then I would like to have adjustable shelves that are made of glass as well. I already have value sets that I can choose here in training, construction door. So here I'm actually just choosing, for example, a frame door with a glass filler. So then I get my frame door with glass, but I still see that I have wooden adjustable shelves here. And now I will set up a descriptor that automatically detects if there is a glass filler, then I will get glass shelves. Of course, there are many possibilities how to do that. You could just do it with variables if you prefer. But just to give you some ideas for maybe other use cases, I would like to show you how it can be done with descriptors. So in this case, I will actually manipulate the name of my article zone. And first of all, I need a variable for this as well. So I create a variable here in my family training construction door. Here I have two variables, one that chooses the part definition for my door and one that chooses the part definition for my filler. And now I create a variable that I call training zone name, and the type of variable is a text. And my default value is wood. So I save this variable, and then I will actually change my value sets for this family. So I have a value set for frame door and a glass filler. And if I choose this value set, I say the zone name must be glass. For my wooden filler, it must be wood. And for my standard flat door, I will just say that it's wood as well. So in this case, I will actually change the zone name by actually choosing my frame doors. But where do I add this variable actually, this text variable? I will switch to my article. And for the article, here on top, you have the article designer group name. And that name can be changed. And that name can also be a variable. So in this case, I think you cannot right click here to choose variables. So in this case, you have to know the name of the variable by heart. So you type in $ and then the name of the variable, training zone name, and save my article. And now it wouldn't work, of course, because I still need a descriptor that actually chooses the glass shelves or the wooden shelves. So in this case, I go to my dividers and drawers. For my shelves, I choose an adjustable shelf. And for the construction principle, I will do a right click on the 3-point button and I choose again a descriptor that I am about to set up now. So here in my training folder, I have a descriptor called training adjustable shelf. It is not set up yet. And maybe I write chooses wooden or glass adjustable shelves. The type of descriptor is a construction principle, and the construction principle itself is an adjustable shelf. And as a default value, I will choose just my standard shelf here with a recess of 20 millimeters. And then I create my first condition. And this condition should be, first of all, wood. In this case, I choose the same principle that I'm using for as my default value, but my comparison now is different to the one that we just saw for the door. So in this case, I'm choosing the zone name. So now I could say if the zone name contains wood, or if the zone name is equal wood, or whatever, then this adjustable shelf should be chosen. So in this case, of course, I say if my zone name is wood, then I will have my wooden adjustable shelf. And if my zone name is glass, I want to get the construction principle that actually uses glass. And the comparison is zone name is equal glass. So this is my descriptor. And now I apply this descriptor and I can try it out. So I will save my article, refresh it, and now you see I still have my wooden adjustable shelves because this variable was just created, so I have to actually choose the value set again. So let's try it out with my frame door wood filler. So let's look inside the cabinet. I have wooden adjustable shelves, or actually particle board. I don't distinguish in this case. And now I choose the value set for the glass. And then you see I automatically get my glass adjustable shelves here. And this is just one example how you can use it. I know that you could also just add it into one value set and control everything with variables, but it should just give you an idea of how you can use these construction principle descriptors. What is very interesting is that you can use these construction principle descriptors not only for construction principles, but also for articles, for example, which means that you can just replace subarticles. You could say, as a subarticle, I need a subarticle that brings 3 drawers or 5 drawers. So depending on the zone height, for example, you could say if my zone height is less than or equal to 500, for example, then I want the subarticle that brings 3 drawers. If the zone height is greater than 500, I want the subarticle that actually brings 5 drawers, for example. Or you could also directly choose it from for the drawers itself. So you could choose drawer principles with it, where you could say, I don't know, in this condition, I want an in-house production drawer. In that condition, I need a two-side frame system, or maybe I need an internal drawer or whatever. Yeah, as I said, there are a lot of ways how you can use these construction principle descriptors, and you have a lot of references here to choose from. You could also combine them. You could say if the zone height and the zone name depend on a certain value, then this principle or this article will be chosen. So yeah, you should maybe just consider when you set up a descriptor, it is always a rule that you define that works automatically in the end, which is very practical because it avoids mistakes, and you as the one that creates the basic data, you can be responsible for that the users of your data don't have to consider too many things. Because of course you can choose a double door with a variable as well. So in my article, I could just replace this descriptor with a variable of the type construction principle, but you always have to consider that at some point variables have to be set manually on a value. And with descriptors, you don't have to, because you just change the width, for example, and then suddenly you have your single door. If I would achieve this same thing with a variable, of course, I would have to change the width, and then I manually would have to change the construction principle that this variable is actually using. So in this case, descriptors have kind of a big advantage because it's like a more automated way of creating your basic data. And you should always consider that to make it easy for the rest of the users that are using your database. Okay, that was a quite small online academy. I hope I could give you some new impressions and some good ideas. If you have questions, I will leave the chat open, of course. And yeah, I hope you liked it, and I hope I see you again next time. Have a great weekend, and yeah, I'm glad if I see you next time again. Bye bye.